Okay, so in this video we're looking at example 3 in our notes booklet for graphs of functions and their inverses. And in example 3 we're checking for inverses using ordered pairs from the graphing calculator. So if you notice these steps up here, steps 1 through 5 in the notes, we're asked in step 1 to enter f of x in y1 and g of x in y2 in the graphing calculator. And if you've been using it for the earlier examples, it's a good idea just to reset your memory and your settings to start with a clean slate. So we're going to go to second plus sign and then type 7, 1, 2, and that will clear your memory. And then second plus sign and type 7, 2, 2, and that's going to restore your default so that you have a fresh screen to start working with. So now when we go to the y equals, everything that we had in there earlier is gone, and in y1 we're going to go ahead and enter this f of x, 15x plus 3. So 15x plus 3, enter, that goes into y1. Okay, g of x we're going to put into y2, and that's 1 over 15, and then x minus 1 over 5. Okay, and then we'll press enter, and that's our g of x then in y2. Okay, then step 2 says to press second window, so we're going to go to this blue second button, and then the window button is up here next to the y equals, and we're going to change the input from auto to ask. So we'll go over here to independent variable and change that from auto, if you're looking in the picture here, from auto to ask by pressing enter, and now ask is highlighted. The dependent variable, we're going to go ahead and keep that as auto. Okay, then in step 3 we press second graph. Okay, so second is the blue button here, and then graph is down here at the end. And this is our table of ordered pairs. You can see it says table up above there. Okay, right now it's blank because we set it to ask us for an input. Okay, so when we enter our input here in step 3, it says to enter 3 x values, one that's positive, one that's negative, and then 0. Okay, so I'm going to go ahead and enter a negative number. So in my example here, it suggests -5, but you could pick any x you wanted. So -5, and notice my output for y1 is -72. So f of x then, when I input -5, I output a -72. Okay, now that means that for the g of x, right, if I input the y, -72, because remember for inverses we switch the x and the y, so if I input -72, my output should be -5. So I'm going to check that in the calculator by typing -72 for the x, press enter, and remember y2 is my g of x, so I'm ignoring this center column for right now because I want to see if the point -72, -5 is on my g of x, my y2, and it is. So the point -72, -5 is on g of x. So this set of ordered pairs shows an inverse relationship. Now it's not enough that one set of ordered pairs works, right? We have to check it for a positive, a negative, and 0 when possible. We want to get at least those down to make sure that it's actually an inverse relationship. So now I've picked a negative value for x. I'm going to go ahead and try 0 now for my x. So when I put in 0 and test enter, right, I'm looking at the y1. So my f of x has the point 0, 3 on the graph. Okay, that means to check g of x, I'm going to start with 3 because I'm switching the x and the y. So I type in a 3, And now I ignore y1 and I just look at the output for y2 because that's g of x. So the point 30 is on g of x, right? And that would be another inverse relationship. Okay, now I've got a negative, a 0. Now I'm going to test a positive value. So if I pick 7 as my x, I type 7, enter. I ignore y2 because I'm just looking at f of x right now. So 7, 108 is an ordered pair on f of x. So I'm going to switch my x and y. So now my new x is 108. So I type in 108 and press enter. I ignore the y1 now and I look at y2 because that's g of x. So 108, 7 is on g of x. So that shows me that this would be an inverse relationship, right? F of x and g of x are inverses because for each of those ordered pairs, right, the x and the y switch positions. Okay, and that means those are inverse relationships. Okay, so when I look at example B here in the notes, I'm given a table that I need to analyze and decide are y1 and y2 inverses or not. Okay, so if let's see if I can zoom in here a little closer so we can see this better. There we go. Okay, so when I look at this table, when I input a negative 10, right, my output is 0.71429. Okay, so then in the next line we input that 0.71429 and I look over at my y2 and the output is negative 10. So I can see that this ordered pair for y1, right, is going to switch, right, and I get the x and y reversed. So for the negative input, right, that relationship is an inverse. Now in the next line, when I put in 0, I get back 0.6667. Okay, and when I put in that 0.6667 as my new input, I get back this interesting notation here, negative 1e to the minus 4. Okay, now that is scientific notation, and it means that there are 4 zeros in front of that e, right? So that would be like, in front of that negative 1. So that would be 0.123 and then my 1, right? So negative 0.123 and then there's my 4th decimal place. That is very close to 0. So why is it not exactly 0? Well, that's because if you notice, these are rounded values here, right? 0.6667 is 0.6666 repeating, it just got rounded. So because we input a rounded variable or a rounded value, we're getting not exactly 0 back, we're getting really close though to the 0. So that tells me that this does hold. This is an inverse relationship because this is really close to 0. Okay, so then my next one that I check, I had a negative value, a 0. Now I check a positive value. So the 0.5, 1.25 is on that graph. When I put in 1.25 for the x, I get out the 5. And so are y1 and y2 inverses? Yes, they are inverses. Okay. So then looking at example C, if you want to pause the video and try that one on your own, and then when you're ready to come back and check your answer, we'll go over that together. Okay, so negative 7, 2 is on y1. Then when I input that 2, right, do I get back a 7? And the answer is no, right? This should be a 7 or a negative 7 here because negative 7, 2 was on y1. 2, negative 7 would need to be on y2 for them to be inverses. But because we get back a negative or a positive 3 instead of a negative 7, this is not an inverse relationship, right?